Such a giant tree can store as much carbon as an entire hectare of rainforest elsewhere in the Amazon. My name's Toby Jackson and I'm a research scientist at the University of Cambridge Conservation Research Institute. I'm interested in rainforests, how they work and why they're changing. This surprisingly tall tree was discovered by Professor Eric Goergens using LiDAR, which is a method of remote sensing using a laser scanner on an aircraft. LiDAR can tell us a lot about the 3D structure of the forest, but there's also plenty it can't tell us, including what species the individual trees are. The only way to find that out, and to verify the height measurements, is to go and see them for ourselves, so that's what we did. The expedition started at Laranjal do Jari in the state of Amapá in northern Brazil. There were no roads anywhere near the trees we wanted to see, which meant travelling 220 kilometers up the River Jari by boat. We were often waist deep in the river, hauling our heavy wooden boats up through the rapids. It took us 5 days, sleeping in hammocks by night, and making as much progress upriver as possible by day to reach the right location. The forests on either side of the river showed almost no signs of human activity or influence. Imagine going 10 days without even seeing the streak of an airplane in the sky. It was a real privilege to travel in such a pristine environment and to see some amazing wildlife. The rainforest here is a vital habitat for many animals. After travelling as far as possible by river, we continued our journey into the forest on foot. On reaching the giant trees, we found that they were actually all the same species, Danesia excelsa, known in Portuguese as Angelim vermelho. The height measurements we'd collected by LiDAR were verified in the old-fashioned way, by climbing to the top of the tree, dangling a rope down to the ground, and then measuring the length of the rope. The tallest tree we found, at 88 meters, is the equivalent of 20 double-decker buses. It dwarfs the previous record holders by almost 30 meters, but perhaps more excitingly, it's probably not the only one out there.
We are here in a very unique region, because we don't have any record about this kind of trees, this kind of size, this kind of height happening in other parts of the Amazon. So we really need to understand what makes this site so unique and so successful to host such giant trees.
LiDAR is an important tool in our research here at the Coombs Lab. It's transforming the way we see forests by allowing us to create detailed maps and compare how these change over time. The Guiana Shield of northeastern Amazonia accounts for nearly 9% of the world's remaining tropical forests, and may contain lots of these gigantic trees, which means that it could be a larger carbon sink than previously thought. But this trip also raises more questions. How long did it take for these trees to grow to such immense heights? Did these trees grow so large because there's something special about the environment, or was it simply because they were too remote to be logged? Will these trees still be capable of growing so large in a changing climate? The fact that discoveries like these are still being made, even while parts of the forest are being destroyed by logging, burning and agricultural expansion, demonstrates how much there is still to learn about this mysterious ecosystem. Giant trees like the one we found are simply awe-inspiring. They remind us how amazing the Amazon rainforest is and how important it is to preserve it.